Problem number 37. It's a word problem here involving bacteria growth in this exponential growth here. So we know that our formula is going to be n of t. The amount after time t here is the original amount times e to the kt. We're going to be measuring t in hours. You might want to, sometimes it's just easier to do it in hours, sometimes it's easier to do it in minutes. I'm going to do this one in hours. And so we're told here an initial population of 100 bacteria is going to be, n naught is going to be 100. We're told it grows to 500, n is equal to 500 at t is equal to 2 hours. And so this sentence of the problem is going to allow us to figure out what k is. So that's going to be 500 is equal to 100 e to the k times 2. Divide both sides by 100. We get 5 is equal to e to the 2k. Take the natural logarithm of both sides. Natural log of 5 is equal to 2k. Divide by 2. K is equal to the natural log of 5 divided by 2. So we have figured out here, what k is. And then in the final sentence, we're saying how many hours does it take for an initial population of 150 bacteria to grow to 300? So in this second sentence, I guess third sentence here, we're being told that n naught is now going to be 150. We want n to equal 300, and we're using the k is natural log of 5 divided by 2, and the question is, what is t now? So this is going to be 300 is equal to 150 times e to the natural log of 5, all of that divided by 2 times t. Divide both sides by 150, and we get 2 is equal to e to the natural log of 5, all of that over 2 times t. Take the natural logarithm of both sides, and we get natural log of 2 is equal to natural log of 5 divided by 2 times t. And to finish this off, we need to solve this for t here. T is equal to 2 natural log of 2 divided by natural log of 5. Let me just point out here, we cannot combine these natural logs together. This is not natural log of 2 over 5. This is natural log of 2 over natural log of 5. We can, however we want, move that 2 upstairs. I mean, the answer that I have here in the black is a perfectly fine final answer. This is equal to natural log of 2 squared divided by natural log of 5. That's natural log of 4 divided by natural log of 5. This is an alternative way to express our answer. Okay, that was problem 37. 38 here is, we have a function f of x is 8 minus 5x. We want to simplify a difference quotient. So, what is going on here? F of x is 8 minus 1 over 5x. And so f of x plus h is 8 minus 1 over 5 times x plus h. So f of x plus h minus f of x, all of that divided by h, is going to be 8 over, not 8 over, 8 minus 1 over 5 x plus, oops, I'm making a mess here. Let's try that again. 8 minus 1 over 5 x plus h, that's f of x plus h, minus f of x is going to be minus 8 minus 1 over 5x. Don't forget there are parentheses there. All of this over h. And we expand out the parentheses, distribute that minus sign, we get 8 minus 1 over 5 times x plus h, minus 8, minus times minus is plus 1 over 5x, all of this over h. Okay, so at this point then, we can cancel out these minus h's, sorry, this minus 8's, and then we're just left with 1 over 5x minus 1 over 5 times x plus h, all of this over h. Okay, let's combine this. We want to further simplify this. Let's combine the numerator into, combine the numerator here into a fraction with a common denominator. To achieve that, we're going to multiply the left term by x plus h over x plus h. We're going to multiply the right term by x over x. And so at this point then, the denominator of our numerator is going to be 5x times x plus h. And then the numerator is going to be x plus h minus x. And what cancels here? Those cancel. And we're just left with h over 5x times x plus h, all of that over h. And the final thing that we can do is that we can cancel h from the numerator and the denominator, and we're left with 1 over 5x times x plus h. We were supposed to discuss where are we using the assumption that h is not equal to 0. Well, if h was equal to 0, we couldn't be dividing by h in the first place. We couldn't be dividing by h in the first place. And then, because if we, at this stage, if h was 0, we'd be having 0 over 0 indeterminate form here. And so the fact that we know that h is not equal to 0, allows us to do this kind of cancellation here. So that's what's going on.